Hello, everyone. This is Srini Lapani, and I'm part of Group One, along with Mauricio, Shekhar, Adi, and Param Singh. This is assignment four for the Data 620 class, and the topic is high frequency words from a select text from an online resource. So, the objective of this assignment is to select a corpus of text from an online resource, find how many total unique words are in this corpus, identify the top 200 high frequency words, and create a graph. And at the end, check if the observed relative frequency of these words follows Zipf's law. So we selected to download A Tale of Two Cities by Charles Dickens, and this is available from the Project Gutenberg. And the source, the URL is listed here. So we use the NLTK package, part of this Python program. And NLTK is a leading platform for building Python programs to work with human language data. It's the raw text from the Tale of Two Cities has 792,000 characters in total, and the first 75 characters are shown here. And you'd see a mix of special characters, characters, as Python represents here, and then the actual text of the story. Now, let's try to find out where the actual story begins in this text, because there is a lot of header and footer information in the source from the Gutenberg project URL. So we manually identified where the story begins, and in this case, it's letter I, chapter one, the period. So using the find function, we get the position of where it starts from. It's 2646, and using the reverse find function, we find where this specific line shows up in the text, which is basically the end of the story, and it says its position is 772,848, and we narrow down our text to basically starting from the beginning and ending at this line, which is this position. So that takes away a lot of the header and footer information. And we also tokenized the data. Tokens are nothing but the words appearing in the text. So the if you see the total number of tokens in this text are 166,500, and here is a sample of 10 of those tokens listed here. We then went on to identify what are the total unique words, not the entire words like 166,000, but just the unique words in this corpus, the raw text. It comes to 9,526, and the top 200 of those are listed here. And at the very top is the word the, followed by and at the very bottom of these 200, top 200, you see the word better coming up 89 times in this story by Charles Dickens. When we plot, we try to plot the 200 most common words, but then as you can see here, the words are very small and not legible to read. So instead, we put top 50, and here are the top 50 words. And from 8,000 for the word D to somewhere less than 1,000 for the word R in this, the 100th word. We then try to remove the stop words. Now, we need to filter out some useless data, which is also referred to as stop words, so that they do not take up space, and they're not taking any expensive processing time. Now, this is a small corpus text, but imagine if we were processing a huge volume of text, the millions of words, this would definitely be handy. So we removed the stop words, and after removing the stop words, what we find is, as shown in this plot, those those other words and their occurrences. So in this case, the word "said" is occurring around 650 times, and the word "father" coming up 200 times. And finally, we try to see if Zipf's law holds good for this text in terms of the frequency of the words. And what we saw was, according to Zipf's law, the most common word occurs n times, then the next common word should occur half of that, or n by two times. So the log scale graph, when we plot, should be a straight line according to Zipf's law. So we tried to plot the same here on the, the words here in the graph on the log, and we see it's not a straight line, it's a curved line. We see here in the earlier case the word "the" and the word "and," 8,000 times and around 4,800 times, which is kind of follows Zipf's law. But after that, it doesn't follow, meaning the n by 2 rule does not apply to the remaining words over there. So, Zipf's law is not applicable here for this corpus of text. And in conclusion, comparing to all text, we think this corpus text uses the same common words that we find across all English language, and but the graph when we graph the Zipf's law, we see that author uses one specific word, in this case "the," more often than any other word. So it could be some other words, something else in a different corpus text. But in this case, it's one of the words that occurs more frequently is the word "the." So, and here, that concludes our frequency of high frequency voice assignment. Thanks for listening.